goes with logic and fault simulation. So when we go before with the logic and fault simulation, as in the previous concepts, we have already discussed with the basic introduction to testing and what were the types of testing and what is about the basic definitions within the faults and testing, how many types of testing we have and what were the faults, and within that also we have discussed within the definitions. Okay, and also we have discussed with the fault modeling. Okay, fault modeling. And apart from all these things, okay, so when we come to the concept of testing, so what is the basic thing of testing? So testing can be representing, that is what, if it is of any electronic device. So if you want to design any half adder circuit or full adder circuit, so on designing of any circuit, digital circuit or analog circuit, so firstly what happened, we'll be checking out what were our requirements. Okay, on the selection of our requirements and the components, we are going to check on each and every component before we are going to build a design of an application. So that is what, so the testing will be representing, so on placing of any component to a structural format, that is what a structural functional format. So we are going to test, we are going to verify each and every device operation or its the manufacturing, that is what the fabrication process. And we are going to identify either the component or the device is working in a very good condition or not. So that comes under the concept of testing basically. But in the testing also, to identify either the device is said to be in a very well good condition of operating level or functional level, so we require to define the identification of the faulting. Okay, where the fault is occurred, what type of fault it is, either it is of signal fault or either it is of a logical fault, either it is stuck at 0 or stuck at 1, or else if it is defined with any voltage fluctuations in the device, or else the faulty occurred based on the type of input signal. Okay, so all these are the terms which we define in identifying the faulty. Okay, so to determine all of these things, so a fault simulation or else a logical simulation plays a major role. So before going to these in-depth concepts of logical and fault simulation, so we need to discuss some basic concepts, how we are going to check on with the test patterns and what is a test vector, and how we are going to define the test patterns, and how we are going to identify the test faulties. So that is what faulties within the circuit, how we are going to identify. Okay, so that is what it is going to represent a test pattern generator. Okay, TPG, we'll be saying that as an TPG, which is said to be as a test pattern generator. So we'll be discussing all these concepts before going for in-depth of logical and fault simulation. And sure, before starting with the main concept, so let me say with a small example, what is this logical and what is a fault simulation. Okay, so let me discuss with a small example. So for example, if a designer who is going to design an executive garment, so if a designer is going to design one garment, okay, so firstly what he does, he checks on with respect to the measurements. Okay, based on the measurements of the written which he has noted on the measurements. Based on that measurements, he is used to cut the cloth pieces into one based on with respect to their measurements. Okay, so once the designer, what he does, he is going to verify the measurements of the written person, and he is going to cut the pieces with respect to that measurements. So that is what he is going to decide. He is going to expect that on designing this garment, it is going to fit to that person or some other. Okay, it is said to be applicable. So before that, what happened? The person the designer who is going to choose the selected pieces. on cutting, after cutting of the respective material, okay, the respective pieces. So he has to identify either the cut piece is said to be true one or a faulty one. Okay, that is what he has to identify. It is said to be a correct piece or a faulty piece. Okay, either it is suitable within the measurement or it is not suitable within the measurement. So what happens, he is going to verify every time by seeing the readings, by seeing the measurements within the paper what he has written. So that is what the designer is going to verify the cuttings, verify the piece cuttings once and every time before he is going to design the complete material. Okay, that is what the verifying of each and every measurement is said to be as a simulation. Okay, which is going to define the term as a simulation. So the idea of simulation is said to be predicting that result of a building, the desired object. So basically what happened, we'll be saying that what is the simulation in the sense, we are going to predict the result, what it is going to get an outcome of the designed application or a designed material or a designed object, okay, which is said to be as a simulation. And in this also, as I said you on, if a person who, if we are going to verify each and every logic operation within the electronic device or any digital device, okay, so if we are going to verify each and every input, either if we consider any OR gate, with respect for the OR gate, we have a if it is of 2 input OR gate, we'll be having 1 output. For each and every input, we will be having within stuck at 0 and stuck at 1, we say. So that is what, so totally we can identify around 6 faulties can be represented. So that is what it is in prediction term. We can define the faulties can be identified of total 6, and within that 6, the each and every on each and every detection of the faulty, you are going to expect some output of the OR gate. Okay, that is what the prediction term is going to define the simulation. Okay, what will be the output and what is the input we have given, and each and every time you are going to verify it. Okay, that is going to represent the simulation process. So